Good day, class. It's Sir Capistrano again, and welcome back to another discussion here in Math 1 Statistics. So, for today, it is just a continuation of our discussion regarding hypothesis testing. And to be exact, we will be just using another tests or another set of tests when we are dealing with comparison or getting the difference between the sample mean and the population mean or the population data. So for today, we'll be looking into one sample t-test. As you may have remembered, last discussion is about one sample say test. This is about one sample t-test. And in that, we will be looking into one sample t-test. It is actually an statistical test for the mean of the population, which is applicable to interval and ratio data, wherein we will determine the difference between the sample data and the known value of population data. So let me just first get some values for our t-testing. Get to open it. So let's go to T, student T. If ever you want to search for the values of T, you just need to search student T distribution table, or you can use the calculator if you want. But for this class, I suggest you use the the T table para sa practice. Okay? So, balik lang ulit tayo. This is the same table that we actually used last meeting. Sorry for that ad. So, in that, let's jump right into our one sample t-test. So, by one sample t-test, this is the same set of tests regarding say test. It is also a statistical test for the mean of the population, which is applicable to interval and ratio data, wherein we determine the difference between the sample data and the known population data. The only difference between one sample t-test and say test is the use of our samples. By use of samples, it is used when the number of samples is not large, it is small. As you may see here, I have some typo because of almost the similarity of the one sample t-test and the one sample c-test. It is used when the number of samples is small, wherein n is actually less than 30. As you may have remembered, our say-test, kailangan pag gagamitin natin siya, supposedly the number of samples natin is greater than or equal to 30. So for scenario that you only have less than 30 samples, we will be using our one sample t-test. Right? So for the in that, let me just show you a diagram when to use your say test or your t-test. The first question there is the sigma known? By sigma, you know that it is the population standard deviation. When you know the population standard deviation, you must use your z is equal to x bar minus mu over our sigma divided by the square root of our n. But whenever the sigma is unknown, the next question is more than 30 ba yung sample size natin? So when more than or equal to 30 ba yung sample size natin? When it is more than or equal to 30, you will be using still say test, but the only difference is you will be using the sample standard deviation. So kapag no ulit, so as you may notice, we will be using the t-test. Okay? So we will be using the t-test whenever the sigma is not available or sigma is unknown, and our population size is less than 30. Right? So those are the conditions when to use our t-test and our sig-test. So for the formulas of our t-test, almost the same formula for our say test. The only difference is we will not be utilizing our sigma here. As you may notice, I still write the sigma there, but we don't have any formula wherein we will be using the population standard deviation. Same set yan. As you may notice there, class, we have here the difference of the means wherein we have the sample mean minus the population mean over the standard deviation or sample standard deviation divided by the square root of the sample size. Okay, so that is the formula for the t-test. And here are the assumptions. As you may notice here, halos parehas talaga. Ayan. For the t-test, your subjects or samples must be randomly selected. Again, and also, population must be approximately normally distributed. Approximately, the is the only difference between the say-test and the t-test. Medyo dapat lang yung t-test mo ay normally distributed. And also, the population mean should be known. Lagi yan. Wala tayong magiging point of comparison kapag hindi mo alam yung population mean. And the cases of the sample should be independent, meaning to say, one sample has no direct relationship or wala siyang effect dun sa makukuha mong result dun sa isa pa. And also, the sample size should be less than 30. Okay? Yun pa, yung isa pang difference nila, the population size should be less than 30. And if we jump into the procedure and how we conduct our hypothesis testing using one sample t-test, as you may notice here, almost the same scenario yung susundan natin. The only difference between one sample C-test and one sample t-test is the use of what we call the degrees of freedom. And the degrees of freedom is actually just uh, n minus 1. So kung makikita nyo mamaya, saan ba natin gagamitin sir yung n minus 1 na yan? So pwede ko naman ipakita na. So halimbawa, uh, your alpha say is 0.1, meaning 10%, and your sample size is say 28. So as you may notice here, you have an n. So pwede na natin compute yung BF. And for the BF, we have here n minus 1. So that will be 28 minus 1, which is actually 27. So saan natin gagamitin yung 27 na yan at yung alpha na 0.1? We'll be using that in our key table. So as you may notice here, we actually have here the DF on the left side. Makikita nyo yan dyan dito. Sa ating left side dito, we have here the DF. And that is the degrees of freedom. And as you may see here, andito natin makikita yung ating alpha. So kung ang kino-consider natin ay one tail na na testing, then we have a DF of 27. Tatapat mo lang yun dun sa iyong one tail na 0.10. So, makukuha mo na yung critical value natin. Wherein for DF which is 27 and 1 tail 0.1 alpha, we have here 1.314 critical value. And as you may have remembered, we use this critical value for our decision rule. Kapag yung t-computed natin usually ay kapag less than siya dun sa ating less than siya dun sa ating critical, we do not reject the HO. And whenever t computed is greater than our t critical, we reject our null hypothesis. Okay? So that is the use of our degrees of freedom. And also, we need to calculate the sample mean and the sample standard deviation for sample t-test. Since we will be using the sample standard deviation, so kailangan natin siya compute. And also, we need to calculate the value of some sample t-test using the formulas given earlier, where we have there our t is equal to the difference of our means over the standard deviation divided by the square of n. So that is our formula for t-testing. Then we will be conducting our statistical decision for hypothesis testing. Ito yung sinabi ko kanina, when yung na-compute mong t using this formula is less than our t critical, do not reject HO or do not reject the null hypothesis. And if our t computed is greater than our t critical, we need to reject our null hypothesis. So, and the last part is stating the conclusion. So the best way to learn this procedure is through examples. And I actually prepared two examples here for this video. So here is the first example. So for the first example, one official from BIR claims that the average salary for fisheries technologists is 18,000. So a sample of 19 fishery technologists salary has a mean of 17,350 and a standard deviation of 1,230. So is there enough evidence to reject the official's claim at 0.01? So, ganun lang ulit yung system natin. You just need to first identify your given para madali na nating magawa ito. Meron tayong sample na 19 and with that sample, we have sample mean which is equal to 17,350 with standard deviation which is equal to 1,230. Oh, may na-skip na tayo agad na na step. As you may have remembered, we need to calculate the sample mean and the sample standard deviation for the one sample t-test. So, goods na tayo dyan kasi binigay na sa atin. And also, we have a mu which is 18,000, which is the claim of the official of the BIR na meron daw 18,800 na average salary ang ating mga fisheries technologies. So in that, let's set up the hypothesis for the step 1. So for step 1, null hypothesis will be we will just say that the mu is equal to 18,000. So that is the claim of our official there. And let's set up our null hypothesis. Walang direction na sinabi. Okay? I-reject lang yung official claim. So, sasabihin lang natin kung not equal ba siya dun sa ating 18,000. Okay? So, for step 2, we need to set the level of significance. It is already set. We have there a 1% or 0.01 degrees of freedom. And for the DF or the degrees of freedom, we have here N, which is equal to 19 minus 1. So we'll have a degrees of freedom which is equal to 18. And we need to determine the critical value of T. So we have here T crit. So tandaan, we need 18 and 0.01. Two-tailed ito. Kasi wala tayong direksyon na sinabi kung greater ba or less than. So two-tailed yung titingnan natin. So two tails, hahanapin mo yung 0.01. So ito siya, sa ikatlo sa dulo. Then, hanapin lang natin yung 18 kasi 19 yung ano natin, yung sample size natin. So, 18, ikatlo sa dulo. So, we have there 2.878. Ano ba? Check nyo nga kung 2.878 niya yung tinitingnan pa. Okay? Pang yun na nga. So, our T critical here is 2. Ano nga ulit? 7, 8. Wait lang. 2.878. Okay, so mapo-positive or negative value man yan kasi two-tailed yung ating scenario. So for the third step, skip na yan, check na tayo dyan. So kung tayo sa fourth step, so we need to calculate the value of one sample t-test using the formula given earlier. So we have here t is equal to x bar minus mu over s over square root of n. Okay? So, i-pull up lang ulit natin yung calculator natin mamaya pagka-plug in natin. So, we have here a sigma or x bar which is equal to 17,350 minus 18,000. So, magkakaroon tayong negative na value dito over standard deviation which is 1,230 divided by the square root of n which is 19. Okay? So, pull up lang natin yung calculator ulit. Gamitin lang ulit natin yung technique niya na tinuro ko last time. So, we will have here 17,350, you just need to negate 18,000. Okay? So meron ka ng 650. You need to divide that with 1,230. And you need to multiply that to your square root of 19. Okay? Square root of 19 is 4.3 something. And if we are to equate this, we'll have negative 2.303. Negative. Okay. So, ang tanong dyan, paano na yung step 5 natin? Yung statistical decision natin. So, para mas malinawan tayo dun sa mangyayari, para lang ma-set natin yung bars regarding dun sa ano. Pasensya rin sa pangit na bell curve. But anyway, ang sabi natin last time, we have here a save value, which is we have here negative 2.878. And we have here 2.878. So kung ilocate natin class yung negative 2.303, actually magpo-fall siya within this line, yung negative 2.303 na yan. So kung makikita nyo class, nasa loob siya ng tinatawag nating non-rejection region. Ang ibig lang sabihin yan, we do not reject the HO. At kung titingnan nyo actually, uh, yung negative 2.303 ay actually larger siya. It is actually greater than our T critical. So, kung kukunin natin yung absolute values nila. So kung kukunin mo yung ano, yung absolute value ng iyong T computed, saka yung iyong T critical, so negative, ano, so magiging positive. So, ang absolute value ng ating T computed will be 2.303. And yung ating tawag dito, yung ating T critical will be 2.878. As you may notice here, our T computed is actually less than our T critical. So, pwede niyong gawin yon para mas makita niyo agad yung mga values na kukunin natin. Pwede natin gawin yung ganong technique. Nakunin mo yung absolute value. By absolute value, kung negative value yan, gawin mo lang positive. At kung positive, i-retain mo lang siyang positive. So, as you may see here, do not reject null hypothesis. So, for the last step, we just need to state the conclusion. So, do not reject the null hypothesis. So, tama tong claim na to. At 0.01, there is no enough evidence to reject the official's claim. That mu is equal to 18,000 pesos. So, pwede natin isulat ng ganyan yung ating conclusion. So, that is our t-testing. So, kung makapansin nyo class, similar lang siya dun sa approach natin, dun sa ating say testing. Ang kaibahan lang dito, class, ay yung kung alin yung critical value yung kukunin natin sa table. Kasi yun yung isa sa mga difference ng t-testing at say testing. So, sa t-testing, kailangan natin determine yung tinatawag nating degrees of freedom para makuha natin yung tinatawag nating critical value. Dun sa say test, mapaano man kung hindi importante kung gaano karami yung sample natin. Basta siya ay greater than or equal to 30, hindi na natin kailangan i-consider yung ating degrees of freedom. So basically, yun yung isa sa mga difference nung ating t-testing at say-testing. Pero kung makikita nyo kanina, sir, bakit po may mga degrees of freedom na more than 30? Eh di ba sir, pag 30 na, usually ang ginagawa natin, say testing na tayo. So, sa say na data, kukuha ng critical values. But, that is not actually true all the time, as you may have noticed, kailangan sa state testing normally distributed yung iyong population data. And in that case, na kapag yung, ano mo, yung population data mo ay hindi normally distributed, usually magtiti-testing pa rin tayo pag consider natin na hindi normally distributed yung ating population data. So in that, we'll be using other degrees of freedom that is actually larger than 30. And for these scenarios, makikita nyo meron tayong 40, 61, 80, 100, and 1,000. So yun yung consideration regarding dun sa ibang degrees of freedom that is actually 30 and above. Okay? So, yun yung ibig sabihin dun sa table natin. In any case, let's go to the other example. Right? So, for this other example, ayan, medyo pahirapan natin kaunti. Hindi ko binigay yung value ng mean at standard deviation dito. But for the given, para lang dun sa ano, meron na tayong mu which is actually 4.25. And for this problem, based on census of PSA or Philippine Statistics Authority, the average family size of fisher folks in the Philippines is 4.25. A random sample of fisher folks family resulted in the following sizes. We have here 5 members, 6 members, 7, 4, 3, 8, 2, and 9. So at alpha, which is equal to 0.10, does the sample average family size more than the national average? So pwede natin yung check. Ano? So for this one, kailangan talaga natin mag-compute. Hindi pa binigay dito yung standard deviation at hindi rin binigay uh, ang ating sample standard deviation. So, we will be using those formula. Kung maalala niyo pa yung mga formulas natin. So, paalala ko lang, para sa mean, yun ay kailangan mo lang kunin yung summation ng lahat ng excess mo. Hindi, you just need to divide that by your number of samples. So, basically for this one, mamaya pakita natin kung paano. And for your standard deviation, this is just equal to the square root ng iyong variance. Wherein yung variance natin is the summation of your excess minus your mean square divided by n minus 1. So, yun yung ginagawa natin sa ating S. Okay? Okay, pwede akong magpakita dito ng ibang way kung paano natin solve yan. But for this one, let's just first proceed with the problem. So, for our null hypothesis, ang sabi dito, greater ba daw? Yun yung ilalagay natin dun sa ating alternative hypothesis. Na kailangan natin lang ilagay na ang mu daw ay greater than dun sa ating 4.25. Meaning to say, our HO is we will have a mu that is less than or equal to 4.25. Okay? So that is our null hypothesis and our alternative hypothesis. Since meron siyang direction, ang ibig lang sabihin nito class, one-tailed tayo. Ano? So, ibig sabihin, papunta yan sa kanan kasi makikita nyo, more than yung nakalagay dun uh, sa ating alternative hypothesis. So, for step 2, ito yung step 1 natin. Punta na tayong step 2. We need to set the level of significance. Nandiyan na yan. Ang alpha natin ay 0.10. Ang DF natin, count lang natin yung ating samples. We have 1, 2, 3, 4, 5, 6, 7, 8. Ang N natin ay 8. So, ang DF natin will be 8 minus 1, which is equal to 7. So, we just need to determine our T critical now. So, going back to the table, ano nga ba yan? 0.10, then 7. So, we have here 0.10, 1 tail. So, ito, ika-5 na column. Then, baba tayo papuntang 7, we will have 1.119. Ang ba ang tinitingnan class? Ay, wala akong tinitingnan. Sabi na eh. So, we'll have here 0.10 sa 7, 1.415. So, 1.415. Okay? So, third step na tayo. Compute for X bar at saka yung ating sample standard deviation. Yung X bar madali, di ba? So, ang gagawin lang natin dyan, we just need to add 5 plus 6 plus 7 plus 4 plus 3 plus 8 plus 2 plus 9 and divide it ng n which is 8. Okay? So, titingnan natin yan. That will be 5 plus 6, 11 plus 7, 18 plus 4, 22, 25, 33, 33 plus 11, ilan na to? 44. Okay? 44 divided by 8. So that will be 5.5. Okay? So, paano naman yung sa sample standard deviation? Kailangan lang natin dyan gawin. Kailangan lang natin kunin yung square root ng halimbawa 5 minus 5.5 square and so on. Pero magiging matagal yan. So, pwede natin gawin class. Pwede kayong gumamit na Excel. Okay? Start lang kayo ng blank book. Painitin nyo lang siya para makita nyo yung yung PowerPoint nyo. Okay? So, palitin lang natin para makita natin yung mga values. So, mga values natin ay 5. Then, we have 6, 7, 4, 3, 8, 2, 9. Alam na natin yung mean natin kanina, pero gusto nyo i-check, pwede nyo i-check yun. Kunin nyo lang yung sum niyan. Shortcut ko dito, hold nyo lang yung alt, then equal, makukuha nyo na yung sum. Then, divide nyo lang yan by, kung ilan sila, which is 8. So, 5.5. Tama. So, pwede na natin gawin. Sa mga values na to, kung 5, minus lang natin yung 5.5. Okay? So, para hindi magbago yung value, lagyan ko ng dollar sign dun sa before ng 11. Yan. Okay? So, drag ko lang yung pababa or pwede select ko to, control D ko. Lalabas yan. Tapos, kailangan ko lang square itong mga ito. Kasi, mapapansin nyo, kailangan daw natin square yung bawat value natin ng ng difference natin. Square lang natin 'yan. Okay? Then ganoon lang ulit. Gawin mo lang ulit yun dun sa iba. Pag nakuha mo na yun, kunin mo yung sum nila. Pag nakuha mo ng sum, yung sum, i-divide mo sa n, which is 8 minus 1. Then we'll have 6. Then, kunin mo yung square root ng 6. SQRT, square root, will have 2.45. Okay? So, shortcut. Parang may matutunan naman kayong bago sa akin. So, that will be 2.45. So, for now, dun sa step 4, kailangan lang natin i-compute yung t. So, para sa computation ng t, we will have there 5.5 minus 4.25 divided by our sample standard deviation, which is 2.45, divided by the square root of n, which is 8. So, balik lang natin yung ating trusty calculator. So, we'll have here 5.5 minus 4.25. Pero kung kaya niya i-compute ng mental yan, walang problema. So, we'll have 1.25 divided by 2.45. Multiply natin yan sa ating 8 or square root ng 8. So, tama ba? Okay, so we have 1.44. Dapat pala kinuha kayo pa yung isa. So, that will be 3. Okay, so we have 1.443. So, kung titingnan natin yan ulit sa graph, para dun sa ating step 5, so, mangyayari dyan, ang critical value natin ay nasa 1.415. Ito yung ating rejection region. Ito yung ating non-rejection region. So, kung mapapansin nyo class, yung 1.43, actually, siya ay nag-exceed na. Nandito siya sa portion na ito. So, ito ay pwedeng nandito yung ating 1.43. Kung mapapansin nyo, outside siya, ano? So, at kung itetest din natin siya, dito siya magpo-fall kasi yung thing computed natin, which is 1.443, is actually greater than or equal to our 1.415. Ibig sabihin, we need to reject our HO. So, reject HO. So, for the conclusion, step 6, ang ibig lang sabihin nito, kukunin lang natin to. So, the average, and may kulang tayong nilagay. At alpha is equal to 0.10. The sum called average family size is more than 4.25. So, yan. Pwede na natin siyang isulat ng ganyan. So, as you may notice, that is how you compute or how you conduct hypothesis testing using t-test kung kayo ay may mga scenario na mas mababa sa 30 ang inyong sample size. Okay? At hindi nyo alam ang inyong population standard deviation. So, in that, that will be all for this video. And again, you may expect a quiz or an activity in our next meeting. So, in that, have a great day. Bye-bye.